Okay, so we're going to solve this particular problem. Write down the equation of the horizontal asymptote of the graph of f. A couple ways to think about it. But the horizontal asymptote, to find that, we can consider what happens to the function as x approaches plus or minus infinity. And that is, when that occurs, this denominator gets exceedingly large, big, 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 and 1 or anything divided by infinity, not anything, but anything smaller than infinity, we won't get into that quite yet, is going to go to 0. 1 divided by a very large number is going to approach 0. So hence, the equation of the horizontal asymptote would be y equals 0, or the x-axis. So to find the derivative, I'm going to use the quotient rule, which is equal to v du. So that's 1 plus x squared times the derivative of u. The derivative of 1 is 0. Minus u, 1, dv, 2x, all over the v squared, the denominator squared, and 1 plus x squared squared. So that becomes negative 2x over 1 plus x squared squared. Then they give us the second derivative, okay? And this is the trickiest part of the question. Let a be the point on the curve of f where the gradient of the tangent, there we go, the gradient of the tangent, okay? Now, the tangent, the gradient of the tangent is found using the first derivative. This is the first derivative here, okay? This gives us the gradient of all tangent lines to this curve. So what they're essentially asking is, when is this function at a maximum? And they're telling us it occurs at point A. So they're asking us, where does the maximum of this function occur? Okay. So it's the same thing as saying, forget that this is the derivative, it's if I gave you f of x is equal to negative 2x over 1 plus x squared squared, and I said find out all the maxes and mins, you would immediately just take the derivative of this, set it equal to 0, find your critical points, and do your testing to find out where there's a maximum. Okay? Well, I already have the derivative of this. They give it to me. It's right here. And it happens to be the second derivative because this is the first derivative. Okay? But the second derivative is the derivative of the first derivative. Hence, I can use it to find the maximum, where the gradient of the tangent is a maximum. Remember, I've always said a derivative gives you the slope slash gradient, the slope of the tangent to the curve, right? Well, they're asking, when is the slope of the tangent to the curve at a maximum? Or when is the derivative at a maximum? And again, to find a maximum, I take the derivative of whatever function and then use it to find a maximum. And they've already done that for us. Okay? They tell me that A is the point on the curve of f where the gradient of the tangent is a maximum. Find the x coordinate of A. Well, that's going to occur, excuse me, at a critical point when this is equal to 0. And the only way that this is equal to 0 is if the numerator is equal to 0. So I'm going to set that equal to 0. I'm going to solve. So x is going to equal plus or minus the square root of 1 over 3, or plus or minus 1 over root 3, to simplify it a bit. So now I'm going to do a sign diagram to see which one of those is the maximum. So I would have negative 1 over root 3 here, and I would have positive 1 over root 3 here. So now I need to do some test points. Well, the question is, can I use 1 and can I use negative 1? Well, what is 1 divided by the square root of 3? Well, 1 divided by the square root of 3. The square root of 3 is greater than 1. So 1 divided by anything greater than 1 is going to be less than 1. So I can use 1 as a test point. So I'm going to use positive 1 here. The denominator is always going to be positive because 1 plus x squared is always going to be positive. So the cube doesn't matter. Okay, it would matter if this could possibly be negative, but it can't. So it's going to be positive. So the sign is going to solely to be determined by the numerator. So if I use positive 1 here, replace x with 1, 6 times 1 minus 2 is 4, that's positive. I'll use 0 here, 0 minus 2 is negative. And I'll use negative 1 here. Negative 1 squared is positive 1. 6 minus 2 is again positive. So a maximum occurs when I go from increasing to decreasing. So the x coordinate of the maximum is equal to negative 1. Ooh, that should be a 3 there. Over the square root of 3. All right. Hope that provides some clarity, and we'll see you next time.